Hello class. I'm trying something new this year called a guided video. If superheroes really existed, these scenarios you're about to witness could actually happen. I'm not trying to trick you, believe me. This is a review for Fat App and Centripetal Force. Enjoy the video, and I will stop at several points to talk about superhero physics. And, make sure you're paying attention, because one of these questions could show up on the final.
Just a different day. Out here trying to get it each and every way. Mama need a house, baby need some shoes.
And welcome back, class. In the previous scene you saw Superman get bombarded with bullets. Each of the bullets is moving about 500 meters per second, and they each weigh about 0.0075 kilograms. It's about a 9mm bullet. The time of the collision is very small. It's about 0.001 seconds for each collision. And given this information, we can put it in a Fat App equation. We can rewrite this equation to find the force as F equals mf minus mi all over the change in t. And then you notice here that mf is gone. Well, once the bullet hits Superman, the velocity is 0, so no momentum is left over after the collision. And we can plug in our numbers from the data we collected, and we get you take negative 500 meters per second times 0.0075 kilograms all over 0.001 seconds. And after you calculate that, you will get a force of 3,750 newtons. That is the approximate force for each bullet that collides with Superman in this scene.
And I'm going to pause it here. The measured distance across the parking lot is 50 meters, and the Flash made it across the parking lot in 1 second. Thus, his velocity is 50 meters per second.
Welcome back. As you just saw in the previous scene, Flash had a cloud form in front of him. This is caused by a drop in pressure by the fast-moving air around him, which causes the temperature to drop, which allows net condensation to form, thus making a cloud.
And welcome back, class. In the previous scene you saw a collision between Superman and a truck. And here, since we use Fat App for collisions, we're going to set up this equation again using Fat App. And you got the force equals mf minus mi all over delta t. And momentum final is 0 because Superman and the truck come to a stop. And the momentum initial is the mass of the truck times the velocity of the truck. And here you get negative 12,165.5 kilograms times meters per second. And the time of the collision is approximately 3 seconds. And once you calculate this all out, you'll have a force of negative 4,055.16 newtons. But for the magnitude of the force, it's just 4,055.16 newtons.
Welcome back. In the previous scene, you just saw the Flash create a tornado. In order to create a tornado, Flash has to be going 133 meters per second, which is how fast the winds in a tornado are. So, the average radius of a tornado is 30 meters. So, we must get the formula F net equals m centripetal acceleration. So, we must substitute centripetal acceleration for what it equals, which is v squared over r. Then we must plug in all of our numbers with units, and then we get the answer 47,170.67 newtons. This is how much force the Flash must endure to create this tornado.
Sunshine, lollipops, and rainbows. Everything that's wonderful is what I feel when we're together. Brighter than a lucky penny when you're near. The rain goes, disappears, dear, and I feel so fine just to know